this. All right. Okay. You ever got the feeling you're going to get up and spoil everything? But anyway, here we go. So, my name is Pete Trevelyan. You're my wife. Got to use the mic. And it's going to be quite fun trying to handle this. And the mic, I've also got a control device. So, well, good morning, everyone. And I hope you're enjoying the sunshine. It's not going to last that long, so make the most of it. So I know you're all desperate to know what the weather's going to be in the next week. It's going to be a lot milder from tomorrow. The westerlies restart, and you better go out and start digging your garden up. And for those of you who are wondering why it was so cold the last week, we had something called a sudden stratospheric warming at the beginning of January. Now, that's kind of interesting if you're a meteorologist. If you're not, it probably isn't. And that's part of the problem of this morning, is trying to connect what I want to say with what I'm going to present, which is really a lot of material from the Met Office website. So a slight correction, I've worked with those who are top in their field. I am an analyst, so I tend to do a lot of IT work and work with the data that we produce. So the people that you will see a little video of, they really are some of the best scientists in the world. So I was looking at this subject and I thought I'd like to put it into context. And so the first third of the talk is really about our relationship and God's relationship with the earth. And then there's a chilling scripture that God will judge those who destroy the earth. And I was quite shocked because until I'd watched the video of Tom a couple of weeks ago and thought about the relationship to the earth and God's relationship, to be honest with you, it came as a bit of a shock because I got so used to everyday life and thinking about what's going to happen tomorrow and what happened yesterday, and I forgot what happened today anyway. And I began to think, well, actually, there's a relationship between God and his creation. And one of the great things about worship is that you discover your relationship with God because it's immersive. And worship is immersive, which makes churches like this quite unusual because you wonder why I'm not an observer, I am immersed. And that's so important. And we find that as people, human beings, individuals, that we can be very isolationist. We can be very, very individual. And heaven's not like that. Heaven genuinely is a place of outpouring. It's a place of interaction. It's a place of relationship. And when I came in this morning and Tom was showing me around everything, my immediate reaction is I wanted to just talk to everybody because I was immersed with people that are clearly lovely. That's why I don't want to spoil it all. But I thought I love being part of a community. So a little bit about why you would listen this morning, and I often say that when I go abroad, sometimes I say, I'm going to compete between you and your email, and we're going to see who wins. And I often feel like that, and I would engage folks. So, for example, when I was often work in America, I would say to them, so how many states are there in the United States? And some would say 50, and some would say 51. But I wanted to involve everybody in what I was doing. Because as you speak to people properly and engage, we all just end up being observers. It's all very abstract. So the first part of the talk, I want to describe the relationship between God and the earth, which I found most instructive. And we can almost get quite theological at times, which I kind of like. So where we start obviously in Genesis, and you know the earth was born, don't you? You know the earth came out of baptism. You understand that? So the earth was part of God's creation through baptism. And you start to think, that's strange, that's very similar to what I might read with Noah or in John 3 about Nicodemus. Everything is born of water and of the Spirit. Think about that. And the earth was born of water and Spirit. And we can look at that, and the Spirit fluttered over the waters of the earth, and it was born, and there was a creation. And it's very important to understand God cares about his creation. God is connected to his creation, just like he is to you. And you and I are part of his creation. And it's very easy to think I was the only one ever created by God. And then you discover there's other people. Then you look at nature and you look at the design. Now I was watching a short video this morning by a guy called Professor Lovelock, who came up with this thing called Gaia. It's not particularly Christian, but what he understood, he said, this does not happen by chance. And he was trying to get, and he was 101 years old, and he said, we are fast losing our dwelling place. The place where God gave us to live, we're fast losing it. And what I'm going to do this morning is be quite factual. I'm not going to go into a debate with the climate skeptics, of which obviously Donald Trump is another, and Vladimir Putin is another, and the Prime Minister of Australia, hottest year ever, by the way, blah, 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 because they all have coal reserves and oil reserves. Don't get me wrong, I'm not being cynical. I'm just looking at, just like you and me, and islands that are being drowned, they're saying, hey, wait a minute, you guys who are very rich are destroying us who live by fishing or whatever we do. And you will probably know the Thames Barrier has been open a lot more now than it ever was. And they're going to have to build another one because of sea rise. And the sea is rising and it's measurable. So you're already living in a changing world. And that's not disputed, it's observational. And the other thing that you have to really understand is the rate of pace of change, or the pace of change. For many people come to me and say, well, the Earth's climate has always been changing. And it has. There's the climactic optimum. There's the little ice age. There are many things. Milankovitch worked out that the climate would change every 23,000 years. And he called it glaciation. He worked it out because the Earth changes its orbit every 23,000 years. And lo and behold, he was quite correct. I'm talking about the last 20 years. That's what I'm talking about. Not the last 1,000 years even. The last 20 years. And when I'm going to present this material, so first of all, just to look a little bit in Genesis, and I love this bit. This is chapter 2 of Genesis and verse 7. And the Lord formed man of the dust of the ground and breathed into his nostrils the breath of life, and man became a living soul. Our very being as a race came from the earth. If there hadn't been an earth, there wouldn't be you and me, would there? So where would the earth be? Where would the dust be? And we are connected. We are part of that creation. That's why it's relevant. I often ask myself the question, is it relevant? Is it helpful? Is it necessary? I want to look into 2 Peter. You can just have to turn to it, particularly just 2 Peter. And I want to read something which is really, in a way, quite amazing. Because Peter often looks back and has things in his epistles which are really quite revealing. So we read in chapter 3 and verse 5. So this is chapter 3 of 2 Peter and verse 5. For this they willingly are ignorant of that by the word of God the heavens were of old, and the earth standing out of the water and in the water. There was a baptism. And Peter often refers back in his writings to the original. Always God says, in the beginning. So like he often says, in the beginning there was, and we have to go back to the beginning, where it all came from in the heart of God. And in the heart of God, he wanted to create a home for you and for me. A real home. And he wanted us to care for it and look after it. And there's some very solemn judgment in Revelation, which we will look at later on. And this connection. And the other thing I want to really emphasize, it's been loaned to us. We don't own the earth. It's not ours to do what we can't just drill. We want to drill and dig where we want to dig. It's not ours. We are custodians of his creation. Yeah. And it's a connection I was reading in, you have to turn to it, in 1 Corinthians chapter 6, that we are vessels. Our body is not our own. He's quite clear about it. What happens in our body, what we do with our body, we give an account for. So what we do with what God has created and given us, we're going to give an account. We are responsible. He's created something and saying, this is for you. Now, the remarkable thing, I've been reading through this, is that God knew what was going to happen. And there's a resurrection for this earth. So I don't want you all go out that door and groaning and groaning and think, oh, that's all I've ever. There's going to be a resurrection. And that's quite clear. Now, you might say, well, why is there a resurrection if we look at because he knew the hearts and he knew the judgment. And he said, I'm going to start again. And you might say, well, isn't that what happened to Noah? Absolutely. Very, very clear. What God did with Noah was to give them a new earth. Think about that. He gave them a new earth. They woke up and it was all new. Everything was destroyed. All things became new. And our new birth, our creation, it's the principle of God that he's given us life. And we have to be accountable to what we do with it. And that's really very interesting because one of the reason why this precious, precious, lovely planet of ours is being raped is through sheer greed. Sheer materialistic greed. And that is why, and an interesting fact, that every nation's debt is measured as a proportion of how much they earn each year. And we never talk about reducing the debt. We talk about the ratio of our gross domestic product and what we borrow as being about right. And the only way to do that is to keep growing. Keep digging more and more and more and trying to create growth. It's very interesting. Everything you hear quoted on the stock market, it's all about growth. Nobody says, well, it's fine now. I think you've had enough. It's okay. It's all right. We're fine, thank you very much. I'm warm, I can eat, that's okay. There's this desire for more. So I'm going to finish there in terms of introduction. And we're going to go on to some short videos, and I'm going to present to you the material from the Met Office, which has been scientifically, therefore, accredited and approved. And I want to present it to you as fact. People say to me, do I believe in global warming? And I say, well, the same as I believe in gravity, really. It's not a faith system. We worked it all out, and we've come up with the answers, and lo and behold, it is very difficult. So let's, I've got the machine, that's true. So, right. Yep. Okay, so we are doing an introduction to climate change. So what is climate? So I'm going to go over a little video from the Met Office and one of my friends, and he's going to tell you all about climate. Do you like that? Met Office is really caught on. All this comes from the Met Office website.
To be able to understand climate change, we need to understand climate. What is it? How does it work? What is the difference between weather and climate? In this short video, we'll explain what climate is, how our climate works, and how different factors affect our climate.
It's not Gravesend.
First of all, let's answer the question of what is the difference between weather and climate. Weather is the elements we see daily, such as temperature, rain, and wind. These can change hour by hour and day by day. Climate, on the other hand, looks at how the weather changes over a long period of time, typically around 30 years. Scientists have been able to define climate zones around the world. Here in the UK, we have a temperate climate. That is neither especially hot nor cold, wet nor dry, when compared to other climates. Ours is a very different climate to that in the Sahara, for example, which is known as arid, because throughout the year the weather is dry and hot. Scientists have to look at how the atmosphere interacts with the oceans, ice sheets, land masses, and vegetation. These different interactions create a climate system, and these interactions, as well as the composition of the atmosphere itself, create a very complex system. The sun also drives our climate. Sunlight provides energy which heats the Earth. Without the Earth's atmosphere and certain gases, our climate would be very different to what it is now. The atmosphere stops the heat from escaping into space. If it didn't do this, our planet would be a very cold place indeed. Certain gases allow the sun's energy through, but stop it from escaping back into space, acting like a greenhouse. That's why it's called the greenhouse effect. The gases responsible for this effect such as water vapour, carbon dioxide and methane, are called greenhouse gases. Scientists explain the heat-trapping effects of greenhouse gases more than 150 years ago. They discovered that, without the greenhouse effect, the Earth would be about 30 degrees Celsius cooler, making it uninhabitable to most forms of life. Greenhouse gases are so effective at keeping the Earth warm that any changes will affect the Earth's temperature. For more information about our weather and climate, visit the climate change pages on our website.
So it's good, isn't it? They're doing a good job, the Met Office. I'm proud of them. 30 years ago, we had nothing like that, I can assure you. So it's not particularly dramatic in the sense of shock horror. It's just the way we measure the world. And if anybody comes to you and says, I don't believe in climate change, you can ask them this question. If there was no greenhouse gases, how much colder would the Earth be? And they would look at you and say, I don't know. You say, well, you ought to know, because you formed an opinion. And if you formed an opinion, you should have done that as an informed opinion. And you could say, well, actually, it would be 30 degrees. So we've always lived in a greenhouse. So it's nothing new. In fact, I love scientific history. And one of the great questions which the Royal Society used to answer, some brilliant stuff, was why is the Earth so warm? So had we been sat here 100 years ago, we would have been having a debate. Why isn't the Earth colder? That's kind of cool, isn't it? Now we're saying, well, why is it getting warm? Well, we answered one question, so we can now answer the other. So we've watched that. The climate change is explicable, demonstrable, and predictable. And the last video we will show you is quite chilling, pardon the pun, because it's talking about what's going to happen in the next 10, 15 years, not 2080 or 2090, 2030. We have a daughter who's 21 years old. As somebody said, we are the first generation to experience climate change and the last generation that can do anything about it. So as a church as in global church, we need to know the truth. And having known the truth, we can present, but remember this. He is the God of resurrection. He would not allow the end game to be a destroyed earth. You understand that, don't you? And we had a lot of deaths in our little church. And as you get older, it kind of gets a bit more common. And this thing called death, don't worry about it. But you know, the Bible calls it sleep. So when you talk about a Christian dying, say they've gone to sleep and they will be raised again. A new creation in terms of their body, their spirit would have already been resurrected. But think about that. Change our language. And our language can get us in a lot of trouble. And we just, no, you've gone to sleep. You remember that little girl? And Jesus looked at her and said, she's gone to sleep. Wake up. And the first thing she saw was the face of Jesus. And then he said, she's hungry. He's very practical. But he's the God of resurrection. They're all moaning and groaning and this and that. He said, little girl, arise. That's how he speaks to us. And she would have looked straight into his face as a resurrected physical being. I love those stories. I love that scripture. I love the way God looks after us. So, well, I can't really pronounce his name, but Svante Arrhenius, Swedish scientist who kind of worked out this stuff was going on. And he would propose a relationship between carbon dioxide concentrations and temperature. 1859, he did that at about 1890. And because nobody ever thought about it before, so it's not new. That's the point. It's not new. Okay. So the lady on the video said 30 Celsius. He worked it out at 15, but then again, he hadn't got a supercomputer like ours. And he called it the natural greenhouse effect. So I want you to think about, you live in a world of a natural greenhouse effect. So don't say, do you believe in the greenhouse effect? Because you live in it. So that's a fat lot of you to think. And he actually suggested that we would raise the temperature by 5 Celsius, and we'll look into that. But it wasn't until 1987 that people were able to validate his prediction. So how could he do that? Well, it's the physics governing it are very straightforward. That's what always baffles me about people when they say, I don't believe. I think, well, it's just physics. Anyway, that's a bit beyond some people. So anyway, they were looking in 1940s, this thing called spectroscopy. It sounds like it's endoscopy, but it's not. You're all right. The doctors aren't involved in discovering anything unpleasant. But the reason for this slide is don't think this is just since 1980, all right? That's what I'm trying to get. So in El Presidento says, I don't believe it. Well, actually, it isn't just one person. It is a building up on scientific knowledge, understanding, and demonstration. So don't think it's some new thing, okay? So basically, he worked out, let me explain it like this. I discovered, I don't know whether you men know about this, but duvets have TOG ratings. Do you know what a TOG rating is? Who knows what a TOG is? I have no idea what it stands for. Well, think of carbon dioxide as having a TOG rating. Now, my guess is that you put a 5 TOG duvet is cooler than a 10 TOG duvet. But is a 20 TOG duvet warmer than a 10 TOG duvet? Well, a little bit. But when you get to 40 TOGs, not only you can't breathe, but actually it's not much warmer than a 20 TOG because you've lost the blanket effect because all the heat from your body is being absorbed. So adding more doesn't change anything. All right? And they thought that's how it worked with carbon dioxide. Then shock, horror, they realized that adding more carbon dioxide would increase the greenhouse effect. And that was significant. And the way they did that was measuring the absorption properties of carbon dioxide. That's a very reasonable thing to do. And the people who did that were called spectrometrists. So you look at your eyes, and you're an optometrist, and these guys look at absorption in carbon dioxide, and they're a spectrometrist. So I think as long as it's got an ist on the end of it, it's very intelligent. And when I speak in school sometimes, I give them key words to go home to show how bright they are. And one of them would be spectroscopy. So you can do that. And we'll tell you some nice big words as well. They don't really mean anything, but it does sound good. And that's very important in science. We're not perfect. So how do we know that human influence has been detected in warming of the atmosphere and in changes throughout the climate system? And there's a number of ways of doing that. So it's not just because the Earth's getting warmer, but we'll be noticing things like glaciers are melting. The Northwest Passage through Canada is much freer. There's hardly any ice now. Things like sedimentation, rainfall rates. You see, moist air is like a sponge when it comes to moisture. So how do you increase the capacity of your sponge? Well, I don't know how to do that, but the atmosphere, you warm it up. So what would you expect if you warm the atmosphere up? More water vapor. Would you expect higher rainfall rates? Actually, last year we had the highest rainfall ever recorded in the Lake District. That's interesting. Floods have become more. Hurricane Harvey in Texas dropped more rain than any other storm in recorded history. Because, it's warmer. Why wouldn't it? 2013/14, we had 4 months where I live, and we had 1,600 millimeters of rain, that's 64 inches. Off the record. When you hear my friends who are not Christians talk about 2013/14, they will say to you, there is no precedent. There's precedent, but no precedent. There is nothing compare. They had what you call the creeping menace, where people's houses were being flooded because the water was coming up through the earth. They weren't anywhere near a river. And it was unprecedented. So there are signs, there's ways of looking at cloudiness. So you see, it's not just because it's getting warmer, but we're getting other effects as well. Believe it or not, the beast from the east last February and early March was linked to the fact that the Arctic was warmer than normal, and it upset the balance between the Arctic and the tropics, which affected our circulation. Right, just keep my eye on the time. I can go on forever with this stuff. IPCC, so the scientists got together and wrote a report. It's a bit like the Frost Report, but you're all too young to know what the Frost Report was all about. but it's a report, and a lot of people got together. Now, some of the editors for that, John Horton, who was my boss, is an absolute Christian. Professor Dr. John Mitchell, one of the leaders, is a leader at a charismatic Baptist church in Bracknell. These are not men who are given to conspiracies. And people who come to me and say it's a conspiracy theory, I say, can you go and talk to my friend, please, and tell him that he's leading a conspiracy? Because I'd love to know what you would think. And he's a very nice guy. He wouldn't tear you apart, but he would explain and say, well, actually, I am a believer, and I'm not a liar, and I'm not part. I've been accused of being a part of a conspiracy. Fascinated me. I thought there might be some money in it, but nothing, apparently. And I thought, well, nobody's told me. And the other thing about conspiracies, you need to know this. The church is assailed by conspiracy theories. Everywhere you look. Now remember this, a true conspiracy can only have a handful of people because nobody can ever keep it secret. So I go to America and there's a conspiracy. They never landed on the moon until they found that they took a picture of the moon and there was the lander. Dropped that one. And then there was the whole 9/11 stuff. And basically, you expect thousands of people to keep their mouths shut. I mean, come on. So all the climate scientists, it's extraordinary that a group of people would have some collective idea of how to fool the world. It is mind-blowing to me. But anyway, so I got off my chest now, so you're all right. We know, I love this second bullet. I love this because it's basic physics. If I'm not going to drop it, it's okay. It'll hit the ground at a certain velocity in a certain time, always. There's an equation that governs it. And I'll tell you what the equation is. V squared equals U squared plus 2fs. F is gravity, S is the distance, okay? U is the velocity you start with, and it'll never fail. It's called gravity. A guy called Newton invented it, actually. He had a bit of a bad time with a rotten apple on his head, and he worked out, V squared equals U squared plus, I know what that is. And actually, the further something falls, the harder it hits your head. That's all part of the equations and basic physics. So if you're doing GCSE physics, I'm not going to do this, you're all right, but I love physics. Now, I'm not going to ask you the answer because you'll embarrass if you get it wrong, but if I drop these two objects, will they hit the ground at the same time or not? Don't worry, don't panic. And the answer is they hit the ground at the same time. Yeah. The reason being is that it's the molecules inside them that are falling, so it doesn't matter how big the object is, everything inside it is falling at the same rate. So one of the experiments they did on the moon, actually I can talk for hours about this stuff, they took a feather and a wrench. There, she's nodding, she knows. Now that's right, you modern generation, they're up with the speed of it, and they dropped the feather and the wrench on the moon, and they both hit the ground at the same time. It's called physics. Nothing, because V squared equals U squared plus 2fs has one thing that's missing, the mass. It's not in the equation, is it? So the final speed has nothing to do with the size of the object. Basic physics. Newton, it's funny, I was with my daughter and we were leaning out the window and I was dropping stuff downstairs, as I do out the window. And this passerby came in and I said, we're just having an experiment, dropping a big object, a little object. And I said, which one's going to meet the ground first? She said, the big object. So we did it. And she went, I said, what are you doing anyway? She said, GCSE physics. So I thought, I don't know what her teacher's teaching her. But it's basic physics. We live in a world, now I'm going to go on a bit now, so you're all right. I believe in God's laws. I believe we live in an ecosystem of God's law. I believe that God said there's going to be a law of gravity. I believe that. I believe that if you push a bicycle pump really hard, it'll get warmer. If you're a builder and you work really hard, you get warmer. These are laws of thermodynamics. These are laws. We live in a world of laws. And they're God's laws. I'm very comfortable about that. So basic physics says we've known about a greenhouse effect. We've observed it, and we know about it. And remarkably, the observations match the theoretical calculations. Okay? So if I was to drop this, you would observe that it would hit the ground at the same time, and therefore the calculations, everything you could observe it, and you'd say, he must be right, because I can observe it. We have this thing, causality. That's another big word I want you to remember, okay? Causality. if you observe something, why is it behaving in that way? And that's called causality. And sin got into the human race, and there was a reason for it, causality. That's why scientists could never explain sin and a degenerate heart. They can't explain that because there's no causality. There is in the scripture. Okay, next slide. I've just done escape, which doesn't really help much. So we can compare observations with models, and we can put these equations, there's physics, and we can solve the equations on a computer, and we can observe whether or not our computer simulations match our observations. And people come to me and say, you don't know about volcanoes, as if scientists have never seen a volcano. I mean, come on. I mean, I was brought up, I love volcanoes. Anyway, and we looked at everything that could possibly influence the climate and took away carbon dioxide and said, can we actually measure and then predict? And that's what they did. Exactly what they did. So they decided, we'll simulate the climate with and without carbon dioxide and just see what happens. What's the observation? What's it look like? So we did that. And then we started to look at what were the fingerprints that we were looking for in climate change. An obvious one, of course, is it's getting warmer. But there are other fingerprints like rainfall totals, like cloud amounts, like the length of the number of frosts, the date of the first frost, the last frost, the growing season, etc. All these things that we can see. So in the first slide, we looked at how the atmosphere worked. And we have radiation coming in at a high wavelength from the sun, a lot of UV light. I once got sunburnt, so I can prove that. And then it warms the earth, and the color changes from the light yellow to the orange, and some of that radiation goes straight back out again. Yippee. Now, I'll tell you another little anecdotal story. During 9/11, they grounded all the airplanes over North America. And the temperature actually changed by 2 degrees because of all the contrails. Because the contrails were no longer reflecting the sunlight back to the atmosphere. That was very interesting. Nobody actually planned that experiment, I might add. But anyway, it was very, very useful. So we have radiation coming in and radiation going out. And the radiation going out is a different wavelength to the radiation coming in, which is why carbon dioxide is so important, because the radiation going out is absorbed by the carbon dioxide. Now, I've got about a few minutes. I want to tell you a story how it works. Carbon dioxide is a molecule. And when it absorbs energy, infrared energy, they vibrate. And it vibrates, and then it stops vibrating and gives the energy back out again. But the energy doesn't just go out, it comes back down. And that's how it works. I had a little video of that, but I'd never got it together. So, how does temperature change with time? And I've tried to be very clear about the time axis, the vertical axis. And you'll notice the first 100 years were quite cool, often below average. The last 50 years have been increasingly above average. And notice how the curve steepens over the last 30 years. Now that's pretty interesting, isn't it? And that's observations. And you'll notice it's not just the Met Office. We have NOAA and NASA. NASA did it from satellite observations. Now, there are uncertainties, particularly in the early parts of the 150 years ago. Okay, and we've measured those uncertainties. We don't want anybody to be in any doubt as to the errors that we are talking about. However, you can see as we've gone on in time, 1950 onwards, the errors in our observations have got less. But look at the rate of change. And that's what's really worrying. It's unprecedented in human time. So here we go. We talked about measuring carbon dioxide. That's how carbon dioxide has gone up by 45% since 1950. That's a lot. And we looked at ice. On the left-hand side, you'll see glaciers have lost ice for the 37th consecutive year. On the right, you see how the Arctic sea ice has declined 13% per decade. By 2050, there's probably likely to be no sea ice in the summer for the North Pole. Now, the Russians love that because they can drill for more gas, which kind of blows my mind a bit anyway. and we look at changes to the weather and rainfall, and you can see all these influences on our extremes, and we're living in a world of greater extremes. So you can look at this on the Met Office website. I don't want to go through it in detail, except these are indicators of climate change. That's what I want you to think about. It's not just temperature. Top left is temperature. Top right is we've got the growing seasons are greater, which for some people is a good idea. Ex-hurricane Ophelia. Top row, third on the right. So what was Ophelia? Well, when I saw Ophelia being forecast last year, I couldn't believe it. I'd never seen a hurricane go over Portugal. I mean, they're supposed to go over the Caribbean, for goodness sake, or Hawaii, the Philippines, not over Portugal. And it went up the west coast of Ireland. Never, ever has that ever been seen before. Why? Because the sea is so warm. And you need a warm sea for hurricanes. It's amazing. I'm an old man. I never thought I'd ever see it. And I came into table tennis to show everybody the forecast of this hurricane. They weren't as interested as I was, but nevertheless. And sea level's gone up by 16 centimeters, wetter summers, more rainfall, and I could go on. But you can read this on the Met Office website. I don't particularly want to go much more detail. So let's watch the video. Don't panic, will you?
A couple of years ago, we noted that the slowdown in global warming had ended and the warming rate had recovered to the values in the late 20th century. And that suggests that the world is continuing to warm at the rate that it has done long term. Other indicators like Arctic sea ice are consistent with that. They're at or near record low. And so there's continued decline of the Arctic sea ice as well, obviously consistent with the high rate of warming. What we've now done is taken the latest observations. These are observations of the atmosphere, the ocean, the land surface, the ice itself. We put all that together, create our best estimate of what the climate is doing today, and then run our computer models out for the next few years to see what's in store out to 5 years ahead. So these are not like the long-term projections of climate. They are more like weather forecasts, if you like, or climate forecasts initialized with the latest observations. So they're our best estimate of what's about to happen next. And for the first time, these show that there is now a chance that we could exceed 1.5 degrees warming in global temperature compared to pre-industrial times. When we run these forecasts, we run a whole bunch of forecasts, not just one, but a whole bunch, to see the uncertainty in what is about to happen. Just like a weather forecast, they can wander around and there is some uncertainty, so we can measure the range of what is possible. And over the next 5 years, it suggests that temperatures will stay at or near record levels, at least 1 or so degree above pre-industrial temperatures. And there is about a 10% chance that at least one of those years in the next 5 years could exceed 1.5 degrees of warming relative to pre-industrial. It's important to note that this is not an exceedance of the Paris ambition to maintain global warming below 1.5 degrees. That agreement, that ambition, is really referring to the long-term average climate. These are fluctuations around that long-term average. And so 1 year could flicker over the 1.5 degree level without breaking the Paris Agreement. So there is still time to meet the Paris Agreement and the Paris ambition, but this very high rate of recent warming and this latest forecast suggests that we rapidly need to reduce emissions of greenhouse gases.
So it's predictable. We've watched the weather forecast for the next 5 years. Nothing alarmist about this. In one sense, it is science. He's one of the most important climate scientists that we have. Actually, it's quite nice because that's where I work, and I could see my office in the background. And I thought, well, show him that. But anyway, and that video shows you, and the blue, top right, what you really need to know is how likely the temperature, it's like a kind of, what's the range of a likelihood? And I can go through the rest of the point being, you can see that there is now a real possibility in the next 5 years, remember this, that we could go above 1.5 degrees in the next 5 years. I'm not talking 50 or whatever, 5 years. So I wanted to leave you with that slide. And I'm going to turn that off if I can, or I can't. If we can just now turn that off, and we're going to finish. So I hope I haven't sort of blown you away with too much side. But I owe it to you. Now, I thought about this. I thought, I'm fed up of dumbing down everything. Who are you? We're all in this. I'm not patronizing. When I talk about carbon dioxide and spectrometry, it's the deal. And I thought, no, I'm not going to be patronizing and say, oh, it could be, because that's the way it is. And all this material is in the public arena. So I want you to know that. But I also want you to know something else that Peter says. Peter's talked about the earth being born, and he says this. Verse 17 of chapter 3, ye therefore, beloved, seeing ye know that these things before, beware, lest you also being led away with the error of the wicked, fall from your own steadfastness. And he also says this, but the day of the Lord will come as a thief in the night, in the which the heavens shall pass away with a great noise, and the elements shall melt with fervent heat, the earth also and the works thereof, the work will be burned up. And John says, and this is the last scripture, and he says this, and this is wonderful. And this is what John says. Chapter 21, and John is in heaven. He's taken up. He said, I saw a new heaven and a new earth. For the first heaven and the first earth were passed away. And there was no more sea. We are Christians. We are part of the new creation. We are part of God. We are observing what God says. But make no mistake, and you can read this, I won't read it now, but he will judge those that have hurt the earth. He knows that. For all those who think there's no limit to our resources, they will be judged for the way they have treated this earth. And what does it say to me? Well, Lord, you are the final answer. You have the final say. But I want to walk softly. I want to walk carefully, that I don't damage that which God has loaned to me to prosper. So it makes me think, just because he said there's going to be a new heaven and a new earth doesn't absolve me from the responsibility of sharing what I know and being cognizant of what I know and being sensitive to what I know. I want to say thank you so much. It's not that easy sometimes to start, but I just want to say thank you, and I appreciate all your attention. I really do. Thank you.
Praise God. Thanks, Pete, for your honesty.